Hi, everybody. My name is Bill Troutman, and I am your math instructor. Today, I'm going to be covering section 5.4 of the book. By the way, even though it says section 5.4, if you look in the book, I think it's chapter 2. They have our chapters and sections mixed up. So just look at set operations. I believe it's section 2.4 in the book. But what's labeled 5.4 in the workbook, set operations, Venn diagrams with three sets. So in 5.3, we talked about doing these problems with two sets. Now we have three sets. The universal set is all numbers, all integers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then here's set A, set B, and set C. So let's find this first one, part A. Well, you always work what's in the parentheses first, order of operations. So that symbol right there is intersection. Intersection. So intersection means what's in common. So I'm going to write the set for what's in common between A and B. So if I look at these two sets, what numbers are in common? If you look, 3 is in common with A and B, 5 and 7. Those are the only numbers that are in common with sets A and B. Okay? So then we still have this symbol and then a C after it. So this symbol is union. Union is a marriage. It's a marriage. In other words, we bring everything in a marriage into one apartment marriage. I can't even spell marriage. There it is. Marriage. So if you look at set C up here, set C is 1, 2, 3, 5, and 8. And then we're going to, that was right there. There's the 8. And we're going to union this with 3, 5, and 7. Once again, union is a marriage. That means it all comes together. A union, everything comes together, but we don't double anything. So if I look at these two sets, let's put all the numbers in order that all come together. There's a number 1 in both. There's a number 1 here. It doesn't have to be in both just because it's a union, a marriage. So all of the first set and all the second set combine into one set. There's a 2. There's a 3. We have 2 3s, one in each, but you only need to put one, or you only have to put 1 3 in there. Then we have a 5. We have a 7 over here, so 7 comes into this set. And then we have an 8. So this is the final answer. C union A intersect B. So first you're going to do the parentheses, find that. We know C is this down here. So then we put a marriage between these two sets. Everything, one of each of those items, go into our final answer. Okay, so let's take a look now. I'm going to go ahead and erase this. And then I'm going to, because it's just a mess, and I'm going to do the next problem. I'm going to do this one down here. So first we're doing C union A. It's a union. In other words, it's a marriage. C and A. So if I do C union A, I'm going to put the set here. A marriage of C and A. Look at C and A and just write down all the numbers that we have. We have 1, 2, 3. 1, 2, 3. Up in A, we have 2 and 3. There's no 4, but we do have in A and C, we have a 5. A and C, we have a 5. We have a 7, and we have an 8, and we have 11. 7, 8, and 11. You see, I take all the numbers from C, 1, 2, 3, 5, 8. 1, 2, 3, 5, 8, they're in here. All the numbers from A, 2, 3, 5, 7, 11. 2, 3, 5, 7, and 11. They're all in here. If you have a number in both, you only write it down once. So that's C union A. Then we're going to intersect this with C union B. So let's do C union B. These are the two, and we're going to do a marriage of these two. 1, 2, 3, 5, 7, 8, 9. 1, 2, 3, 5, 7, 8, 9. Do you see? I have all the numbers. It's a marriage. 1 and 3, 5, 7, 9 for B. 1, 3, 5, 7, 9's there. And C has a 1, 2, 3, 5, 8. 1, 2, 3, 5, 8. Do you see there? All these numbers are, one of them's in at least B or C. So now that we have both of these, we did the parentheses first. Now we're going to intersect the two. What's in common with both of these? So we're going to create our final last set notation. And what's in common? What's the intersection? They both have a 1. That's the intersection. They both have to have it. They both have a 2. They both have a 3. They both have a 5. They both have a 7. They both have an 8. This one has 11, but not this one. This one has a 9, but not that one. So 9 and 11 don't go in my final answer. They have to be in both of them. That's the intersection. What's in common with both? So this is the final answer. All right. And on this page, there's actually one more problem. I'm going to bring it up. A intersect B not. So I'm going to go ahead and clear all this out. And I'm going to rewrite the problem. It says A intersect. It doesn't say intersect don't look like that. It says A intersects with B not union C not. B not union C not. Let's make sure. That's it. Okay. So first we're going to do in the parentheses. However, this symbol right here means not. Things that are not in B. So we're going to do not B and not C. So let me do right here. Let me do a not B and show you what that set equals. Well, here's the universal set. These are the only numbers. This first one is a universal set. These are the numbers that we're only dealing with. Things that are in the universal set that are not in B. That's what not B is. B has a 1. B does not have a 2. 2 is not in B. B has a 3. B does not have a 4. B does not have a 6. B does not have an 8. B has a 9. B does not have a 10. And B does not have 11. So this is not B. And we also have to find a not C. So let me write a set of everything that's not in C. We have a 1, 2, 3, number 4. Oh, by the way, I'm missing one of the things that's not in B. Does anybody see what number I'm missing? It's in the universal set 0, but it's not in B. So there's also a 0 here that's not in B. There we go. And there's a 0 that's not in C. C has a 1, 2, 3. It does not have a 4. It has a 5. It does not have a 6 or a 7. It has an 8. It's missing a 9, 10, and 11. So 0, 4, 6, 7, 9, 10, and 11. That's an 11, that last one. So we want to find the union of B not C. We want to find the union of these two, B not and C not. So I'm going to create a new set with the union of B not. So everything in this union, and it's a marriage. So I have a 0, I have a 2, I have a 4, I have a 6, I have a 7. Do you see there's a 7 here? There's an 8 up here, 7, 8, 9, 10, and 11. That's this right here, B not union C not. And then we're going to intersect this with A. And let me just write down A since it's already up here. 2, 3, 5, 7, and 11. So there's A, and then we're going to find out what's in common, intersection, common with this other set, B naught union C naught. So the answer of what's in common, they have a 2 in common. There's no 3, there's no 5. There is a 7 in common with both of these, and there is an 11 in common with both of these. So 2, 7, and 11 is the final answer. Oh, nice. Okay, let's see what else we got. Oh, and this problem is this, yeah. In this page, we're constructing the Venn diagrams. We're going to draw the Venn diagrams. So, I mean, it's not the easiest thing to do at first. So let me give you a few tips. We're going to have we're going to have and if you look at the previous Venn diagram, let's look at the previous one. Oh, they didn't even give us a Venn diagram. Let's look at the previous Venn diagram. There's no Venn diagram. I'm going to go back in a couple pages till I find one. There's one. Do you see? First, you have a box that's a universal set. All the numbers are in there. Then you have what's in common with this one and what's in common with that one, and then the stuff that's not in the set. So just take a quick note. And so we're gonna do this right here. Construct a Venn diagram. So first we have a box that's the universal set. All the numbers will be in this box. So that's my box, and that's the universal set. All these numbers 0 through 11 will be in my box when I'm done. Now look at A, B, and C. Is there anything in common? By the way, here I'm going to put A, B, and C right now. Let's look. Is there anything in common with all three A, B, and C? Do you see A, B, and C does have something in common? They all have a 3. They all have a 5. 3 and 5 are the only things in common with A, B, and C. I'm calling this A. I'm calling this B. And I know they overlap A and B because they have numbers in common. But there's another one, C. All three of these have numbers in common. Do you see all three have 3 and 5 in common? That's where it goes right there. All three have that in common. And another way of looking at this is, hey, B is in red. A could be in purple. And C could be this color, whatever this is. This is more purple, I think. And do you see 3 and 5 are in all three of those? 3 and 5 are in all three of those. What's in common with just A and B? If we look, we have 3 and 5 already taken care of. Are there numbers that are in common with A and B? Do you see how 7 is in common with A and B? 7 is the only number in common with just A and B. So we put that 7 here. Do you see how it's in both A and it's in B? 3 and 5 are in A, B, and C. Okay, so we got the 3s, we got the 5, we got those 7s there. Is that what's in common between B and C? Let's look at B and C. Do you see how the B's and C's have a 1? And that's it in common. So between B and C, there's a 1 in common. It's not with A because it's not in common with A, but it's just in common with B and C. Those ones there. All right. And we have one more. What's in common with A and C? A and C has a 2 in common. A and C has the number 2 in common. And that's it. A and C have the number 2 in common. So let's look in A for the numbers we did not use. We did not use 11, so we put 11 in A. Do you see it's in A by itself? B has the number 9 that we didn't use. It's only 9 is only in B. It's not in anything else. And C has the number 8. C has the number 8 all by itself. No other set has 8. Now we used 1, 2, 3, 5, 7, 8, 9. 1, 2, 3, 5, 7, 8, 9. We're missing a 4. We're missing a 0. There's no 0. Look at the universal set. Should have a 0. We have 1, 2, 3. We're missing a 4, 5. There's nobody has a 6 in it. And 7, 8, 9, and nobody has a 10 in it. These numbers are in the universal set, but they're not in A, B, or C. So that's why we put them, you see, outside of the circles, but they're still in the universal set. And this is how you would construct a Venn diagram. And I'll do one more. Here we go. So if I'm going to construct a Venn diagram, here's my box. I could make it a little bit better. So before I draw it, I just want to check to see if there's anything in common with A, B, and C. See, if there's something in common with A, B, and C, that means we're going to have 3 circles where the first one, the second one, and then the third one. So they all have something in common right there in the middle. Do you see they all have A's in common? B's, E's, no. F's, no. So A is the only thing in common with all 3. Right there. Do you see how all 3, I'm calling this set A, this set B, and this set C. Small a is the only thing in common with all 3. Let's see what's in common with A and B, just A and B. D is in common. That's a bad. D is in common, and that's it. So D is in common with A and B. Do you see? Only A and B. It's not in common with C. So D is with A and B. Is there anything in common between B and C? Yes. Between B and C, we have a P in common. So we put a P here between B and C. Now we're looking for A and C. A and C have E's in common. E's and F's. So A and C have E's and F's in common. They both go in there. A and C have E's and F's in common. So let's look in A what we don't have in any of the others. We don't have a B, so B goes by itself. In set B, K and N go here by itself. And in set C, everything, we're missing an X. There's not an X, so we put an X here. The only thing left is what is in the universal set. A is in our sets, B is in our sets, D is in our sets, E is there. I see an E right there. F, yes. K, yes. M. Do we have an M? I don't see an M unless I covered up. So M should be in the universal set. N is there. P is there. X is there. Y. I don't see a Y, so Y is also in the universal set. So we should have all the letters covered. A, B. Wait, where's B? Oh, there's a B. C. No, there's no C. A, B, D, E, F, K. This could drive you crazy. M is over here in the universal set. N is there. I think that's an N, yeah. P, X, and a Y. So Y is in the universal set also. All right, so that's what our Venn diagram looks like. All right, let's see what else we got. Okay, so use the Venn diagram to find the following sets. So all we're going to do is list, in this first problem, list everything that's in A. Look, these are all the numbers in A. Just look at the big circle A, and all of these are the numbers. The letters. So we have an X, a P, R, S, B, F, E, and G. I would put them in order from alphabetically, but those, you get the gist. All those numbers are in A. Look at A union C. This one is A, and this one is C. So all we do is a union is a marriage. We're going to write down all the numbers in A and C. And I'm just going to go XPRS, XPRS, EGBF, EGBF. Those are all in A. And then, those four right there are in C also, but you only write them down once. But here's some more that's in C. MN, MN, and then H and K. H and K. And this is A union C, a marriage of everything in A and everything in C. Okay. All righty, let me erase this now. Next is B union C and then not. So we're going to do B union C first. B union C. A marriage of everything in B and C. All B's are RSWT, RSWT, BFMN, BFNM, and then everything in C. Here's some things in C: EG and HK. So these are all the letters in B union C, but we're looking for the not. So finally I'm going to put it over here. So finally over here is B union C not. So we're looking in the universal set, all these things, we're looking for the letters that are not in B union C. B union C. In other words, that's not in B or C. This is not in B or C. E is, G is, B is in B, F is in B. So do you see X and P are not in B or C? However, there's two more letters that are not in B or C: Q and V. Q and V. So this is the final answer. In order to get to this, I had to find B union C and then find out what was not in it. That symbol means not. Let's do this last one. I'm going to erase this all. A intersect B with intersect, A union B with intersect not C. Oh, Lord. So we're going to do, we have it right here. So first we're going to do A union C. Everything that's in a marriage of A and C. So A has XPRS, XPRS, EGBF, EGBF, and then left things over with C. These are in C, MN, MN, that's an M, Lord. and HK. So that's a marriage of A and oh no, that's not right. A of A and B. I was doing A and C, I think. A marriage of A and B, a union A, union B. So everything in A and B, these are all the numbers in A and B. X, all the letters X, P, R, S, W, T, B, F, E, G, M, N. Those are all in A and B. And then we want to find things that are not in C. Not in C. Well, here's C, all this big circle. See, these that I'm circling are not in C. You see, those are not in C. And I'm going to make it a little bit, we're supposed to be doing an intersection. Now I'm going to make it a little bit bigger. All the numbers that are not in C are X, P, R, S, W, T, and these two. That looks, I'm not sure what that letter is. I think that's a C and a V. Those are not in C. And so we're doing an intersection. We're doing an intersection with this. What's in common with this and this intersection? What's in common with these two? And you can see it gets a little messy if you're really not neat. X is in common with both of them. P is in common with both of them. R and S. W, no. T, yes. T is in common with both. C, no. And a V, no. So these are the numbers, the letters that are in common. X, P, R, S, and T. That's our final answer for that problem. Wow, that one's a mess. You really have to be very careful about this, take a look at it and understand what you're doing. Just don't go from down here at number D. Don't try to get straight to the answer. You have to do it in parts. Do the stuff in the parentheses first. Oh, let me clear this. Let's see what this does. Venn diagrams to prove the following equates to. Okay, it says use Venn diagrams. Okay, we're gonna draw a Venn diagram. Are we on the same section? I didn't even check to make sure we're still on the same, because these are not 3 sets. These are only 2 sets. Oh, there's a 3-setter. 5.5. There we go. That's the end. So we're going to create a Venn diagram and prove this. So here's my box. And here's my A. And here's my B. Things that are not in A, I'm going to, let's see. Let me shade in things that are not in A in yellow. Let's see if I can do this. You see right here it says not A. I'm going to shade things that are not in A or in green. Do you see all of this is not in A? I'm going to color it all. I'm not exactly sure how they want us to prove this, but I think this might work. Other things that are not in A right here, this is not A. So not A is everything colored in there. The only thing that's not colored in is that circle with the A in it. There's a little bit part of the B, but that's still not A, right? So everything that's not A is the yellow, the orange, or whatever color, this kind of greenish yellow. Now I'm going to do another color of things that are not. Oh, no, you see, that's not A. And this is B. So I'm going to shade in B in this green color. So I'm going to do all of B in this green color. What? B in is this green color. So we want to find the intersection of the yellow. We want to find the intersection. Where is the yellow and the green touching? The intersection. Where is it in common? Do you see the place that it's in common? I'm going to draw it. Is right here. The yellow and the green are in common that we both colored are right here. That's our answer to A naught union B. Oh, that's the intersection. That's the intersection. Now we're still not done. The answer, they're saying now what's not in this dark black area. You see, everything else is not in the dark black area. So the actual answer, I should have did dark black at the end. The actual answer then would be the red. Everything else that's not in the dark black. The actual answer would then be everything else that's not in the dark black. Boy, that's so the dark black is the only thing that's not shaded in red. All right, that's a really tough one. But we're not done. We got to do the other side now. We have to do the other side. So here's a universal set. We have A and we have B. So first we're going to shade all of the A in yellow. All of just the A in this yellow. There's A. It's all in yellow. Then in this other color, I'm going to use blue. Everything that's not in B. You see, this is not in B. This is not in B. All this is not in B. So blue is my answer. Everything that's not in B. Oh, it's a union. That's A and this is not B. And it's a union of A not B. So everything that's colored is the union. And so if I color just everything that's colored, because we're going to bring in just the color, you see, everything that's colored is my union. So these two pictures should line up. Do you see these two pictures should match. Everything in the red over here is the answer, and everything in the red over here is the answer. And do you see I have the same stuff shaded in on both sides? I mean, if you do a really good color, the only thing that's not shaded in here is the black. The only thing not shaded here is the white. Do you see how they both have the same stuff shaded in red? And that is the answer. It just shows that they both equal each other. That would be a hard one on a test. I don't know how you would show that on an actual test. And this is something similar. I'm not going to do this one, but you're just showing that they equal each other. Okay, so it says use symbols, unions and intersections describe the shaded region. I think there's more than one way of describing the shaded region, but we're going to try it now. Do you see that all of A and B is shaded in except the stuff that's between them, that's in common with them? So So we want to do everything except, wait, use the symbols to describe each shaded region. I'm going to say the way to do it is without that universal. See, that universal set is not filled in. So if I say, I'm trying to figure it out. Give me a second. Okay, so let's try this. I'm going to use yellow. To start, well, let me use black to write this down. A intersect B. Watch this. A intersect B is this part right here, right? So that's A intersect B. What's in common with A and B right there? So I'm going to clear that off, and I'm going to do A intersect B, and I'm going to say not. That means everything that's not in the intersection, and I'm going to paint it in this yellow here. Everything that's not in the intersection, that's the whole thing. Everything except the white space. You see? All of this is not in the what's in common with A and B. All this is not what's in common with A and B. That's my. Now, I'm going to do an intersection. I'm going to do an intersection with a union B. What? So let me do A union B, a marriage of A and B in blue. You see, all of A is going to be in blue, all of A, and all of B is going to be in blue. It's a union, A union B. So here's the blue, and on the A intersect B is the yellow. So what's in common? The intersection of these two. What's in common with both of these? Where is it both colored in both colors? Do you see? Just in the dark area. Just in the dark area has the color in both. So that's what we wanted to do, indicate the shaded area. And just using these symbols, and I just did that. That's a really tough one. Wow. You have to really be creative thinking about that. I mean, that took a little while, at least 2 or 3 minutes. Let's look at this. This problem, I think this one's going to be easier. This is A. Do you see how just we're going to represent the shaded region? A is shaded. So this is all of A that's shaded. All of that's taken care of. The only thing that's missing is this right here. And we're going to say a union of A, a marriage of A, and that little region right there, and this region right here, by the way, this region right here is B, what's in common with B and C. Do you see? So if I say what's in common with B and C and a marriage of all of A and the union of all of A, we have our answer here. That one was a little easier. And I think that's it for this section. Yeah, the next section is section 5.5. Let me know if you have any questions.